Good afternoon, esteemed judges and fellow students, and welcome to PolyU's pitch about AI-enhanced ground optimization at airports to reduce the carbon emissions in the aviation industry. In the aviation industry, some of the largest carbon emissions are due to inefficient ground operations. This is because of high engine idle times, high congestion due to schedulability inefficiencies, and high taxi distances for large airplanes, and that is because of inefficient gate assignment. All of this causes extremely high carbon emissions at airport grounds, and this causes global warming. That is why our team of engineers and computer scientists, along with the help from some of our advisors, have come up with a solution called EcoFlight.
Introducing EcoFlight, a software empowered with AI to predict the ground emissions of the airport, as well as giving optimized routing paths for the airplanes. We are not only helping airports and airlines to reduce their net carbon emission, we are also focusing on the passengers. So, what do we actually do? EcoFlight is a software that will be implemented under the existing air traffic control system. We have three main features. First is predicting the engine start time. So airplanes are not like cars, right? For us to turn on the engine and move on so quickly. Pilots turn on the engine and wait till the ATC gives them the command to make sure everything is ready to take off the flight. However, this idle time at the boarding gate causes a lot of carbon dioxide emission. And there is no quantitative method in the existing world to predict this engine start time as well. So that is what at EcoFlight we are doing. Our second and third features are optimizing the taxi and routing path, as well as giving efficient gate assignments and takeoff assignments. We will be considering features such as the aircraft type and the engine type to predict these routing paths. So here's our UI. As you can see, this is a ground map of the Hong Kong International Airport, and in the top you can see how efficient our model is, as well as how much we have reduced in terms of carbon dioxide. Once you click a particular flight, you can see the estimated engine start time as well as the takeoff time. And in the left panel, you can see what kind of aircraft it is and how much that particular aircraft has reduced in terms of CO2. So let's move on to our AI model.
So now let me introduce the underlying AI architecture behind our EcoFlight. So our model is basically composed of four modules. First, we input the aircraft data, airport data, and the weather data together and feed them into a multi-head cross-attention layer where we can get the most exact representation of the current state. After we get the previous state, historical data, and the current state together, we can combine them together and feed them into an LSTM module, which can extract the most significant features that matters in our prediction. Finally, they are fed into a prediction module where we can predict the optimal engine start time and the gateway taxiway assignment. After that, here's our business strategy.
We have two customers. Firstly, the airports in any region, and secondly, the airlines that fly into that airport. For airports, our service package targets the fact that airports lose $6.6 billion every single year due to delays and inefficient scheduling. But by EcoFlight's AI model, we can reduce this by 23%. This is through improved ground operations, less congestion due to efficient gate assignment, and AI-powered predictive planning for takeoff assignment. Although we save approximately $1 billion for them every year, we are only charging $10 million as a blanket subscription, and every month we will take 10% of how much they have saved that month due to our AI model. Similarly, for airlines, we are targeting the fact that they spend $10.6 billion every year on fuel. We can reduce how much fuel they spend at ground operations by 14%, and we also have added benefits. This is through the fact that we give the pilots engine start time windows to minimize idling engines. We also reduce delays, increase efficiency, and we also provide them with a way to have better customer relationships. Airlines also have a goal to be net carbon neutral by 2050, so EcoFlight helps to accelerate them in achieving this goal. Totally, our estimated revenue is approximately 15 million every year once we have established and are working at the airport. We plan to move on from HKIA into the rest of the customers around the world.
People nowadays care more about how many revenues we would increase from the capacity, but we care more about the emissions we couldn't save. So we can be a pioneer in greener aviation. This figure may not seem that significant, but every single step we make really matters in our fight against climate change. We will have a long-term development goal to capture more data with a more enhanced, powerful model for increased efficiency and lower emissions. This is a goal for the shared industry by 2050. That's our EcoFlight, together for greener aviation and a greener future. Thank you.
Do you know what drives the pilots when to start the engines? And why the airlines wish to queue earlier for takeoff?
We've spoken with a few pilots from PolyU itself, and from the current situation at airports, pilots are not really given a time that they should start the engine. They usually use intuition and past experience to know when they should start the engine. So because of this kind of a very qualitative way of knowing when to start the engine, there are instances, and it's not very rare, for them to start the engine too soon or too late. So through EcoFlight, we can actually give them a more quantitative way to know when to start the engine, so that the idling time of the engine as well as delays later on are reduced.
What is the incentive of airlines, the planes, getting the queue early for takeoff?
I think this is heavily related to the efficiencies of the entire operation of the airport, because they want most to utilize the resources of the entire airport. They want short time intervals between two different takeoffs of the airplanes. This is a fundamental reason, and they can provide more ground services in advance. When they queue, they get enough time for the ground services and the staff to come there.
Do you understand why Cathay Pacific always choose the gates at the Y? Because that's the closest to the emergent taxi point. So they are priorities. Thank you.
How do you know that number? Because we don't have the ideal picture of how the airport should be operated.
Right. Yeah. So the way we calculated this number is because we see how they are right now. We have the data, we have the actual data of how much time they take to taxi through our database that we are using to train our model. And we've run the AI algorithm, and we've seen how much percent we can reduce this time by. And we figured out that on average we can reduce this time by 14%. So that's why we can say, since we are reducing the time by 15%, we are reducing how much fuel they're costing in that much time.
Add a little bit details about our AI model about how to calculate this exact number, because if you have remembered that previously I described that there was LSTM module, which is called long short-term memory module, in the third module over here, the purple module. This one is basically capturing the previous states and current states, and the information passed to the prediction module. It is like when you pass through the time, at some time you will say that this one you should start engine now, but at the previous it will not say you will start engine now. So we can take the data about when he announced that we should start engine now with the average data we get from our database, because we do have such kind of open source database who's saying that the exact starting time of the planes, and we can calculate an average. And comparing our AI models, the time frame of our AI model with the database average any start time, we can calculate such a number.
How do you quantify the savings without getting into an argument?
So as we can see, Cathay Pacific, for example, they already calculate their carbon emissions. So they would have their source of data. We would have our source of data. So if we were in any argument, we have data to back each part up. So I guess in that case, it would be more of a who wins the fight kind of.
Thank PolyU's team. Thank you.